Hi, I'm Mr. Evans, and today we're going to take distance and displacement one step further and go past our challenging 2D problems and start working to try to solve these problems in 3 dimensions. And by 3 dimensions, I mean in both north-south, east-west, and also up and down. This would imply we're working in both the x, y, and now the z axis. So let's go ahead and very quickly review some 2-dimensional because that will be very important as we move forward with the 3-dimensional. And so again, we've done plenty of examples now to where you have, one side with 4 and one side with 3, but it's in 2 different directions. And I've asked you to solve for displacement. So similar to distance in 3D, all you have to do is add them all up. And so in this case, the distance is, as always, 4 plus 3, which equals 7. And so in this video, I'm not even going to focus on distance a whole lot because hopefully if you've gotten this far, distance is becoming second nature. And so if you remember, to solve for displacement in this, you're making that straight line from start to finish. And this requires our a squared plus b squared equals c squared. And so in this case, you have 4 squared plus 3 squared equals c squared, which is 16 plus 9, which is 25 equals c squared. And so your displacement in this one is 5. And so that is how you solve in 2 dimensions. And so now we're going to go a step further and start attempting to solve 3-dimensional questions. And there's actually 2 ways we can do this. And so I'm going to show you one way, and then I'm going to show you the other, and it's up to you to really focus on whichever one you want to use for solving for problems on here on out. So let's begin by getting an example drawn. And so, let's do almost something similar here. We could do 4 meters and 3 meters again. However, this time I need to show that, we've gone east here, 4 meters east, we've gone 3 meters north, but also we've gone ... Actually, I'll even use a different color here to make it a little bit easier to recognize. And so our purple here will represent that we've also gone 5 meters up. Okay, and so we've gone 2 different directions on the ground and then a direction up, and so we've covered the x, y, and z axis. Okay, and so what we can do now is we can solve this problem 2 different ways. We can solve for the direction on the ground, and we've done that before, right? And so if we solve for this line here, it's a squared plus b squared equals c squared. And since these are the exact same numbers, 4 and 3 as before, we know that that line is going to equal 5. Okay, and so if I redraw this over here, we have 4, we have 3, and this line here equals 5. And so now that we've solved, this line here, what we've actually done is now we can redraw that line up here. And so our displacement on the ground is 5, and our displacement into the sky is 5. And so what we've done is essentially created another right triangle. And actually, I'm going to go ahead and redraw this here just to better represent a right triangle. And so as I said, we've created a right triangle here where now we have 5 along the ground and we have 5 straight up into the air. And so hopefully you can already begin to see what you got to do. It's another right triangle. And so essentially to solve a 3-dimensional equation, you do a squared plus b squared equals c squared once to make a triangle to represent the ground. And now we're about to do it a second time to solve for the triangle that represents the ground and the sky. And so, if I can erase some of this stuff that's kind of in the way down here now, we can show that we have 5 squared plus 5 squared equals c squared. So we have 25 plus 25 equals c squared. 50 equals c squared. And so now we're going to do the square root of 50 equals c. The square root of 50 is 7.07, and so your total displacement is 7.07. And so if I go ahead and redraw our initial question here, which was 4 meters to the east, 3 meters north, and then 5 meters up, what we've actually solved for is the displacement from our initial spot to our final spot, which is both to the north, to the east, and up in the sky. And so what we solved for is right here. But as I said, there's actually a second way to solve this. And so if you didn't understand that, or if you did, but you want an easier way to solve it, let's remember there that our answer was 7.07. And so I'm going to write that just right up here in the corner. And we're going to do the exact same problem, but now the second way. And so we have 4, we have 3, and up in the sky we have 5. Okay, and our second way now is, again, a squared plus b squared, but we're going to go one more dimension. So plus c squared equals d squared. And we can even consider d stands for displacement. It doesn't matter. And so now what you have here is a, b, c, and d is this line of displacement. And so we have 4 squared plus 3 squared equals 5. Oh. And so now what we have is 4 squared plus 3 squared plus 5 squared equals d squared. And that would be 16 plus 9 plus 25 equals d squared. So we get 50 equals d squared. Then we do the square root of both sides, and we get 7.07 equals our displacement. Okay, and so you can see got the exact same number. And so either one works here. You know, my preference would be the second option. It's all one nice neat equation. I think it's quick and simple. But if you prefer the other method, go for it. As you can see, they both work. And so that is how you solve for displacement in 3 dimensions. Please feel free to post comments or ask me any questions to help clarify that. And if we were to take it one step further, we'll start working with how to solve for 3 dimensions with multiple different units, as in meters, millimeters, centimeters, kilometers, and so on.